All right, well, let's go ahead and get started. My name is Stuart Regis, and I am recording the first lecture for CSE 142 in our very unusual spring quarter of 2020. I normally spend the first day talking about the class and kind of my philosophy behind it and so forth, so I'll do some of that. We'll do a little bit at the end to talk a little bit about some Java programming, but University also has asked us to have a somewhat slow start this quarter to give people time to get used to the new technologies that we're going to be using this quarter. I'm not sure about the rest of you, but for me, I'm grateful that the university is letting me come in and record a lecture in a gigantic empty room. I think that it'll help me to feel grounded, that every Monday, Wednesday, and Friday I'm going to be doing something that kind of anchors me to the class and keeping track of what day of the week it is and so forth. I would strongly recommend that each of you try to do something similar. You could watch the lecture during the regular time you've been assigned for section A or B, or some other convenient time on Monday, Wednesday, Friday. But I think it would be helpful if you would make it a regular thing that you're going to watch the lecture, not get behind on the lectures, and then be able to participate in other ways. Let me say a little bit about myself. This is my 34th year of teaching, and I've mostly taught intro computer science. I did that for 10 years at Stanford University, and then another 8 years at the University of Arizona. I came here 16 years ago, so this is my 16th year of teaching at the University of Washington. I designed the 142 class that you guys are going to be taking, and it's been a fairly successful approach. My co-author and I, Marty Stepp, we wrote a book that is the required text. We've sold 80,000 copies of the book, so there seem to be a lot of people who think that this is a reasonably good way to teach computer science for intro students. Introductory computer science courses are kind of notorious for having a very high failure rate, and that's not true here. We do not have a high failure rate. I think that if you follow along with the resources that we're going to make available, I think you'll do well. You don't have to be particularly good at programming in order to be able to do well in this course. I used to say things about the increasing interest in the computer science major, maybe to get people interested, but I don't think I need to do that anymore. I was checking this morning on the UW website, and it showed that computer science is by far the most popular major on campus these days. So I think most of you are aware of that, that there's just been an explosive interest in computer science as a major, and lots of people want to do it these days. What you may not be as familiar with is that our computer science department is a very high-powered program. So we've been a top 10 computer science department for a very long time, but I think we're moving up even within that group of the top 10 departments. People generally agree that there's a four-way tie for number one between MIT, Berkeley, Carnegie Mellon, and Stanford, that those four schools are all the top computer science programs. We're in the next tier down from that, but a lot of people are kind of, I think, thinking that we are maybe the fifth computer science department in that list. The state of Washington has been very generous in terms of resources they've given us to be able to ramp up to this very large number of undergraduate majors, and we've used those resources to hire a lot of very high-powered faculty. So, and even if you don't become a computer science major, this is something that's affecting the entire campus. So people who do things like data science and machine learning are working with departments across the campus. And so you might very well end up benefiting from it, even if you don't end up becoming a computer science major yourself. There's a computer scientist that I tend to quote a lot that I wanted to mention a little bit about. His name is Don Knuth. He's probably the most famous living computer scientist. He's at Stanford University. I've thought about, they sell a T-shirt that has this "Knuth is my homeboy." I've thought about wearing that on the first day of class, but I'm not sure whether that would add that much to it. But I certainly feel a lot of affinity to Knuth and things that he says. You might think that Knuth might be offended by people making fun of him a little bit with something like this, but Knuth is actually, he really appreciates this kind of humor. So he posed with somebody who had the "Knuth is my homeboy" T-shirt. So Knuth himself, his first publication was in Mad magazine, which is a humor magazine, when he was an undergraduate. So, Knuth's a funny guy. They've even made the meta version of that T-shirt, which is, I lost the meta version of it. Okay, technical glitch. There's a picture of this picture. They made a T-shirt out of this picture, so you could kind of call that the meta T-shirt. It's a T-shirt of a T-shirt. Well, what I did want to talk about a little bit is I wanted to mention a specific quote from Knuth, because I think it captures something useful to understand. So Knuth said, "It has often been said that a person does not really understand something until after teaching it to someone else. Actually, a person does not really understand something until after teaching it to a computer, i.e. expressing it as an algorithm." I think this is probably the best simple explanation that I've seen of what computer scientists do. I think that what we spend our time doing is figuring out how to teach the computer to do things for us. And one of the interesting things is that it has become more and more true, particularly in this century, that everybody needs to learn how to teach the computer to do things for them. Doctors, nurses, lawyers, engineers, everybody has to learn how to use computing to be able to do these things for them. So I like this description as kind of a way of thinking of what it is that we're doing in computer science. Another thing that I thought I would mention is that Knuth believes that there is a particular style of thinking associated with this. He calls it algorithmic thinking. And he believes that it's different than other kinds of thought processes, so that it's not mathematical thinking, it's not quite what you do in a logic class, it's kind of its own style of thinking. Knuth thinks that when you do computing, when you take a programming course, for example, you're practicing using a part of your brain that you don't normally use. And I've heard this from many students, so I wanted to mention two different students and kind of that I have in mind when I'm teaching the course, and relative to this quote, the idea of the quote. So the first student that I'm thinking about is, you guys have been filling out this survey that we do every quarter, and one of the things that we find in that survey is that the most common answer students give for why they're taking the course is that they want to learn about programming. I think there are a lot of students in this class who haven't done a lot of programming and want to learn more about it. They want to experience it. So I feel like a lot of students are going to kind of have this experience of seeing what it's like to think in this different way, to experience this different way of thinking. And so I kind of think of it almost as being like a foreign language course or something, where you're learning a different style of thinking. And I think that many people will take the course and find that one course is enough. Kind of that was enough, exposure to programming. They're glad to have experienced it, learned a little bit about it, but they're not particularly interested in going beyond that. Some other people may take our second course or a third course, but not go all the way to becoming a computer science major. So that's kind of the student that I have in mind for the course. So I'm not planning for people who've done a lot of programming, or for the students for whom this is really, really easy. That's not the student that I'm thinking about. I'm planning for a student who wants to spend a quarter experiencing algorithmic thinking, that wants to come to this course, have an experience where they can explore this, learn more about what it's like, so that they'll be able to interact better with people who are doing this, later in their career. And I want to make sure that this course is not something that somehow destroys students like that, who are kind of here more for the exposure, and they're not necessarily people who are going to become computer science majors. So I have in mind somebody who has never programmed before, might be a little bit nervous. That's the student I'm planning for. Probably the student that is least happy with the course is someone who has done a lot of programming already, because then I think they're going to be bored with what we do here. But, that's the way things are. I mean, I plan the course around the absolute novice. I think that's the right thing to do, to make sure that the course goes at a pace that's appropriate for someone who's learning everything for the first time. So that's the student that I have in mind. I work really hard to try to make sure that 142 is a good course for someone who has never programmed before. And so you'll see that we kind of build up these topics slowly to make sure that we've taken enough time that someone who's never programmed before is going to have a good experience in the course. There's a second student I wanted to talk about, though, that we sometimes have. I describe them as interest changers, and our admissions committee has picked up that phrase that I've used. There are some students who end up taking this course, and they find that this thought process, this algorithmic thought process, is something that they actually enjoy. And they might enjoy it enough that they would consider becoming a computer science major or otherwise making programming a significant part of what they do in their career. And I see a lot of students like this. That's kind of one of the most fun things about teaching a 142 class, is that you get to have students who are surprised that they like it more than they thought they would like it. And we know from statistics we gather within the computer science program that there are men who are in this category. I mean, my co-author Marty Stepp was someone who didn't think he wanted to do this until he took an introductory programming course from me in 1999 and decided that he really liked this and switched into computer science. So there are men definitely who are interest changers in that sense. But it's more often women, about twice as many interest changers, women are interest changers as men, in our program at least. So I guess what I would say is that I hope that you would reserve the possibility that you might end up being very interested in this material, and that you might want to go on and do more, either in the major or taking various non-majors courses and making a part of whatever else you're going to end up studying. Anyway, so that's a little bit about my ideas behind the course. I want to talk about the structure of the course. Normally this is a point in time where I tell the TAs, pass out the syllabus to everybody so they can see a copy. That's not, obviously we're not going to do that. Most of you probably have already gone here to the course webpage, but if not, I wanted to remind you of the simple URL that you can use. So this is a shortcut. It kind of takes you to our latest 142 course webpage. So in a minute, I'm going to go over there and kind of go topic by topic to tell you about various things we're going to do. Let me mention briefly that the big change this quarter is that we're not going to have a midterm or a final. I like having a midterm and a final. I think that it lets us find out things that we don't just through homework scores, but it's just not practical this quarter. There are a lot of instructors who are thinking of things like maybe they would record what students while they're taking an exam and check the recordings to make sure that nobody was looking at a cell phone or a computer or something. I just think that it's not something that we know how to do well. I'm trying to keep things simple. I think it's going to be a challenge this quarter no matter what. So I'd kind of rather go for the simple things. It's always been the case that the homeworks are the core of what we do in the course. They're the most important part of the course. So I'm going to kind of just use the homeworks this quarter. So that's all that you have to focus on in terms of thinking about your grade. We have to put our focus then on trying to make sure that you have the resources that you need in order to be able to succeed with those homework assignments. Maybe I'll mention one other idea before we start looking at some of these different things. I did want to mention that I think that the way that 142 is designed, we give you tons of resources. So there's a textbook that goes with the course. I wrote it, so it goes well with the course. My co-author, Marty Stepp, had made a series of lecture slides, PowerPoint slides. I'm not a PowerPoint fan, so I don't tend to use the slides very much, but I think they're a useful resource. They're a nice summary of things that we did in lecture. I'm going to be recording these lectures so that way those are available as well. For the textbook, we made various short videos that are available as well. So there's tons of resources that we're going to make available to you. Then there's the discussion sections that we're going to have, and you'll have a TA who's running that discussion section. And so I guess what I would say is that I think that we go out of our way to give you more resources than you need in order to succeed in this course. But it's important then really that you put in the effort to figure out which resources are going to work for you, which ones to use, and so forth. So I find that there are some students who don't do well in 142 because they skip the lectures or they don't participate in section. I think it's and it's going to be even more important this quarter because you don't have the motivation of being in a room with people. You're going to have to find the discipline to make yourself watch the lectures. Don't get behind, keep up with the lectures that we're doing, participate in the weekly discussion sections, use the other resources like the textbook and so forth, if that's helpful to you. Well, let me switch to the class webpage so that we can take a look at some of these things. I guess I'll begin by bringing up the syllabus so we can go through some of the different topics there. So I will be having office hours through Zoom on Tuesdays from 1 to 3. If you go to the Canvas page for the course, you'll find, I think, my office hours are already included there. We're going to be doing section through Zoom as well. We haven't added those yet, but that'll be coming in the next couple of days. The textbook is Building Java Programs, 5th edition. If you have access to an older edition, that would be okay. But if you're going to buy one, I would recommend you buy the new one. It has material that's helpful for both 142 and 143. There's a description here of the course. I do mention, which I've already been talking about, I do mention at the end here that if you're someone with prior programming experience, you might want to just skip 142 and go directly into 143. We let students do that. So if that's something that you wanted to do so that you won't be bored here, that would be fine. As I mentioned, I'm planning for the student who's the complete novice. I mentioned the discussion section here, that we're going to have our 50-minute discussion sections done as a Zoom chat room. This week, the section will just involve kind of getting to know each other and learning how to use the different features in Zoom. This is probably going to be happening to you in other classes that you're taking. And again, as I said, the university has asked us to have a bit of a slow start, so there won't be any Java material that we're likely to cover in the section. We're mostly going to be just kind of getting used to the new setup. Of course, web page information here, course registration. It's been very confusing, dealing with all of the issues here and not knowing for sure what's going to happen. I believe that our course administrator might still be adjusting sections. So we will offer the sections at those specific times. Obviously, the rooms don't matter because we're not going to be going to any of those classrooms. But the times will matter. So I believe he might be doing some load balancing by moving people from one section to another, but I'll have more to tell you about that on Wednesday when I record a lecture, and that'll be before the Thursday sections. We will be starting lectures this week on Thursday. As I mentioned before, the other thing that's mentioned here in the discussion section, let me just mention that attending section will get you 3 points, and it's capped at 20 total. So you only have to attend 7 sections out of the 10 that we're going to have in order to get full credit. So there's no reason that everybody in the class shouldn't get 20 out of 20 for your section participation score. And homeworks are mostly 20-point homeworks. We're going to have 8 of them. So this is like a 9th homework. It's like an extra homework where you can all get 20 out of 20 just by participating in section. So that's one of the smaller ways in which we try to reward participation in the class. In the grading, normally I would have talked about exams and so forth, but since there aren't any, I mentioned that we're doing grading based on homework. We're still using our normal distribution where if you end up with a 90%, that guarantees you a grade of 3.5, and 80% guarantees you a 2.5, and so forth. We don't know exactly how it's going to turn out. It seems likely to me that we'll end up giving higher grades this quarter. That happened last quarter when we canceled our final and just had the midterm and homework. We ended up giving a higher percentage of 3.5s than we normally do. So that seems likely to happen this quarter as well. But these scores basically are guarantees that if you reach that milestone in terms of the total, the percentage of the total points available, then that's the grade you would get. Our late policy is described here. One thing to keep in mind, so we will have due dates, and one of the important things to notice is, this is mentioned towards the end, is that you must turn in the homework within 3 days of that due date. So it can be up to 3 days late. But after that 3rd day, we cut off the homework. So be careful, not to have a homework be too late. But I describe in here the idea of late days. So if you miss the 11 p.m. deadline for a certain due date, you have until the next 11 p.m. to turn it in, as for 1 day of lateness. The next 11 p.m. would be up, 2nd day of lateness, and so forth. We normally give students 5 free late days because we say that, you'll be sick sometime this quarter, or something will come up, you'll have a family issue you have to deal with. And so we just want to grant everybody 5 free late days because we assume there's going to be things that would require that kind of support. I have decided this quarter to give you 10 free late days. I think that it's going to be tough on all of us. There are going to be issues where you might not be able to get the help that you need in a timely manner, so it might take you a little extra time to get the help that you need. So I just decided it would be better to give everybody 10 free late days instead of 5 free late days. So there's a lot of flexibility there in terms of how you will turn in your homeworks. Let me mention the collaboration issue. This is an unfortunate aspect of 142, is that we have a non-trivial amount of misconduct going on in the class. So you're not allowed to work with other students on the programming assignments. And you're not allowed to, the most common one that we have these days is that people are going online and looking up solutions from other people. One of the things you should realize is that if you can find a solution online, we can find that same solution online. So that's not what you should do. I mean, the policy is very clear here that you should not be looking up online resources. You should not be working with other students. You should not be asking other students to help you to be able to solve the homework. Now, there's other stuff that we're going to do. We will have class examples, the textbook, section problems. For most homework assignments, I have a targeted sampled program that's kind of meant to prepare you for the homework assignment. And for all of those resources, the ones that aren't the homework, you are allowed to discuss them endlessly with other students or with your TA. So there can be tons of interaction and collaboration with all of the other resources of the course. But when you go to work on the homework, I want you to do that yourself and not rely on looking up resources online, not be talking to other students. So it would be great if we had a quarter where we had less misconduct than we've had recently. We do take it very seriously. We put a lot of effort into trying to make sure that students have done the work on their own. All right, well, let's see. Let me just take a look at some of the other features. I'll be showing you some of these more in the days ahead. There's a calendar tab here. So I don't know quite what calendar we're going to follow. You know, this calendar was set up assuming that there was going to be a midterm and a final. So there may be some adjustments that I end up making. But I've shown you kind of more or less the order in which we're going to go through material. I may update it, as I said. What you're going to find is that later today, I'm going to post resources here under the entry for today that will include the lecture slides that I mentioned. If there are any little practice programs, I'll include those. If there's any code that I've written in class, I'll include that code here. So you don't have to be trying to write down or type in code that we do. I think that in general, the lectures go better if you mostly sit back and absorb and listen to what's going on. So that's one of the reasons to give you all of the code that we end up writing, so you don't have to try to create it on your own. So there'll be a lot of resources that appear here on the calendar, and as we go through the quarter, that'll happen each day, as there'll be kind of more resources there. Homework I'll talk about later in the week when we go to release homework. We have labs normally for this course. So you have a Thursday discussion section. We've often had a Tuesday lab where, you know, it's intended for the people who are interested in doing a little extra practice with things. So we're thinking particularly about the absolute novices who want a little bit of extra practice. There's a 1-unit, 190 lab credit that you can earn for doing that. We haven't decided for sure whether we're going to do labs this quarter. We normally would have started them this week, but we don't want to do that. There's too much going on for us to try to start the labs this week. We're going to be figuring that out later this week, and we'll let you know. So it may be that we'll be doing the labs starting next week. This Java software link is one that you can follow to get instructions for how to set up the same kind of Java setup that you'll be seeing me use on my computer. There are two parts of that. There's the Java software itself, something we call the JDK. So that's one thing that you need to have on your computer. And the other thing is a programming environment. I use the JGrasp programming environment. It's a very simple environment. It tends to not have very many configuration issues. So I think it works well for novices. If you have your own programming environment that you've used before and you want to use that, I mean, for example, there's an environment called Eclipse that a lot of professional programmers use. If any of you know Eclipse, if you know some other environment, you can certainly use that other environment. We don't require that you use JGrasp. That's just kind of the recommended one. So course staff doesn't have very much information right now other than about me, but I did want to point out that one of the things that's here is that I have a form for giving me anonymous feedback. So you can also email me just directly, with your name, but I think that this quarter in particular, there'll be times when maybe you want to give me a comment about what's going on in lecture or other kinds of things, things you might be upset about. You can use this anonymous form. I will not know who you are if you submit a comment through that anonymous form. So that's under the course staff. Message board isn't set up yet. We'll tell you about that. I'll mention practice it later. Maybe the last thing I'll mention is just that we're going to be doing some things that I call engagement activities. We haven't set up this page yet, coming soon. But normally we do what are called exploration sessions, and that's we organize talks on campus. we're going to do a lot of programming in this class. So we're going to be focusing on Java and Java programming. And there may be people who find that they enjoy the programming, but then you're kind of like, but what would it be like to actually work in computer science? I mean, where does this lead? Where would I end up if I was going to do that? So we've often done that through exploration sessions. That's going to be harder to do this quarter. So we may do some things that are sort of like that. We might make you watch a TED Talk or something, or read a paper and write about it. But we also want to just have some activities, I think, that try to encourage you to be engaged with us, engaged with the course, engaged with your fellow students. So we're trying to think up things that would be good to do. I have 2 TAs who are assigned as engagement TAs. They're going to be trying to think up different ideas. One idea I had is that maybe we're going to have question of the day, where we'll have kind of some interesting question, and I'll tell you the answers that people give. So I'm already put together the first question of the day. I'm going to make that available on the main page. So later today, when I put the lecture link here, I'll also put a link to question of the day for Wednesday's question. And so I'd ask that you give me your answer by the end of Tuesday. So Wednesday morning, I'll check and see what your answers are. The first question of the day that we're going to do is just asking you where you're going to be spending spring quarter. Are you in Seattle? Are you in Washington? Are you in another country? So very short answer, a very simple thing to be able to do. And we're going to ask students to suggest question of the day. So if you have some ideas of something that you think would be an interesting thing to ask other people in the class, you'd be interested in seeing their answers. And it doesn't have to be anything serious or anything to do with computer science. It could be something fun, all sorts of things. So what we're going to do is that students are going to be allowed to suggest question of the day, and if we pick one of your questions, you'll get a tiny little bit of credit towards your homework score. And there'll be other engagement activities also that get you a tiny little bit of credit. We do that with our exploration sessions as well, as we have an opportunity to get a little bit of credit. So I didn't have a question of the day for today, but maybe I'll give you an interesting fact that you might find it interesting. This quarter, normally I'd say look around and you can see. Obviously you can't do that, so let me tell you. This quarter we have 48% women in the 142 class. And that is the highest percentage of women that we've had in a 142 class ever. So, I'll say, I've been here since 2004, keeping track of statistics since then. It's the highest percentage that we've had in the entire 16 years that I've been here, including summer quarters where we tend to have a higher percentage of women. And it seems to be that we have almost as many women taking the 142 class this spring as we had last spring. So the difference is not so much women, the difference is with men, that we have fewer men who are taking the course this quarter. So anyway, we're happy to have women still signing up for the course, and it's going to be, I think, really interesting to have such a high percentage. We've always been interested in trying to get to at least 50%, in the class. So we're very, very close this quarter. All right, well, I think those are the things I wanted to say about the syllabus and the course structure and so forth. What I want to do for the rest of the time is to spend a few minutes showing you some basic things in Java. So we're going to be beginning in chapter 1. Now, on the calendar, I'm going to include kind of the sections of the book that are relevant for whatever we're going to be talking about. And what I would say about that is that different students will approach the reading in different ways. You may find that you understand what I do in lecture and you don't need to go through the reading. You may find that you want to kind of review the reading afterwards. Some students like to do the reading before the lecture. So it's kind of up to you. It might be worth at least skimming through what's in the different reading because not everything is going to be included in lecture. So sometimes it's good to review that. Well, I have JGrasp. I opened it up before I began so that I could do this for you. So this is that programming environment known as JGrasp. It is an editor that allows us to create our programs, and it also lets us run our programs. So what I'm going to do, there's a tradition in programming classes in computer science that the first program you're supposed to show anybody is a program that produces as output hello world. You know, it's kind of an old convention among programmers. And I think that one of the reasons that that's a convention is people figure, how hard could it be to produce just the two-word output, hello world? Well, Java actually is the poster child for how really complicated it could be to produce the hello world program. Java is an object-oriented programming language. We're not going to be talking so much about the object aspects of it at first, but one of the things about that matters is that everything that you include in Java needs to be included in what's called a class. So I'm going to define a public class called hello, and I'm going to include a set of curly braces so that whatever I put in between those curly braces is considered to be inside of the class. So you'll notice that JGrasp put the word public in purple and the word class in purple. That's because those are special Java keywords that have a special meaning, and so JGrasp is just letting you know those are these keywords. This is something that I made up. Classes in Java are required to start with a capital letter. So, and you can't have any spaces in the name. So I'm calling it hello is the name of my class. So we begin with that. But in order to be able to have a class that can be executed, that has code in it that can be run, you have to have something special that's known as a main method. Now, what I just typed here on this line is I typed 2 slash characters. That's used to create what we call a comment. So comments are bits of text in your program that are just there for a person to read. They just kind of give you useful information. So I was just typing main method so that you'd know that that's what I'm about to type here. In terms of how the slash works, basically when you do a slash, everything from here to the end of the line is considered a comment. And then the next line is no longer part of that comment. All right, so let me show you what a main method looks like. You have to say public static void main string bracket args, and it has a set of curly braces as well. Wow, what a mouthful. Public static void main string bracket args. This is normally when I'd make a joke to the class that, if you want to leave now, you can, if this is getting way too complicated. This is one of those things where I'm going to basically ask your indulgence that you not worry about all of the details of what's in this public static void main string bracket args. A lot of people almost memorize it as a kind of, that's what you have to do when you want a main method, public static void main string bracket args. So for now, just kind of type that in without worrying about the different pieces. It turns out that it's going to take us all the way to chapter 7. So not until the 7th week of the quarter will we get to the point where we'll understand all of the different things that are included in this line right here, this public static void main string bracket args. Early on, there were some introductory instructors who went to Sun Microsystems that controlled Java at the time and said, can't you simplify this? And they said, why? We said, well, for our students. And they said, why are you teaching novices Java? They didn't care, basically. So, I mean, it is worth recognizing that we are using an industrial strength programming language where, you are learning a language that professional programmers use. And as a result, sometimes there are going to be things that are a little bit on the ugly side, and this is one of those. Let me mention something about the curly braces. So you'll notice that there's a set of curly braces for the class and there's a set of curly braces for the method. We're going to see that consistently with Java, that curly braces are used as a grouping mechanism. Another thing that JGrasp does that's nice is if you hover over one curly brace, it'll show you the matching curly brace. Or if I went to this curly brace here, it shows me the matching curly brace. So that's a nice feature of the editor. Now, some people kind of like putting their curly braces like that on a line by itself. So maybe here you'd put the curly brace down here. That's not the style that we use. That would be an okay style to use if you want to, but it's not the style that we tend to use. We tend to put the curly brace at the end of the line, instead of putting it on a line by itself. Okay, so I'm going to have a main method. What I can put inside of my main method are various commands. So a sequence of commands. So the command I want to give is system.out.println. So this is system is the name of a class, and by referring to system.out, I'm actually referring to a particular object. We'll talk more about that later. And I'm asking it to do its Println command. This is one of the places where Java's a little odd. I don't know why they didn't do print line. You know, that would make a lot of sense. The Java generally uses very long names for things. But this is a place where, for whatever reason, they decided to use Println instead of, print line. So anyway, that's the command I want to give, is I want to do the Println command for this object that's known as system.out. We use a set of parentheses. Inside the parentheses, I'm going to tell the Println command what I want it to print. And I'm going to put a semicolon here. Every command has to end with a semicolon. So inside of a method, not just the main method, but all the methods, and we're going to talk more on Wednesday's lecture about how to define your own methods, other methods besides main. But inside of a method, you have a command, semicolon, command, semicolon, command, semicolon. So a series of commands that have semicolons at the end. Now, I can't put the ... here. I have to actually say what it is that I want it to be printing. Now, I want it to print out hello world, but hello world, those are not Java words. Like here, even something like hello has a special meaning in this program where it's going to be something that's referring to the name of our class. This hello is just, I don't want that. I want the text, capital HELLO. I want it to do literally that text. And so there's a mechanism for doing that in Java. We put it inside quotes. So I'm going to put a quote here and a quote here. By putting it inside quotes, a series of characters, I'm creating what we refer to as a string constant, or it's sometimes called a literal constant. I am stringing together a sequence of characters, and I mean literally capital HELLO space WORLD exclamation mark. So that's my Println command. I'm telling it to do hello world. It's inside of a main method, which is inside of a class. Okay, so I think I'm ready to see whether my program looks right. The first thing I have to do is something that's known as compiling. So, let's go. Thanks, JGrass, for letting me know. I want to save this program. And JGrass knows that a class called hello, should be stored in a file called hello.java. So we'll go ahead and save that. So first thing is this process that's known as compilation. This little plus sign here does the compiling. You don't have to worry too much about this. Chapter 1 talks about it. But basically, it's converting the Java file into something that is more easily executed by the computer. You'll see that after we compile, it will have created a file called hello.class. You don't have to worry about those files. That's just the compiled version of your program. Now, down here, we did not see any response from the compiler, which is good. That means that it compiled successfully. When you compile, you can then run. That's this little running icon here. And there's the output, hello world. So that worked, which is good. All right, well, suppose I wanted to have a second line of output. I could, let's do this. I could say second line. And then we could go ahead and hit compile for this. Some of you may have noticed, I did that on purpose. I put Println instead of Println. So I was trying to introduce an error. The compiler, you never quite know how many error messages you're going to get. Sometimes one error produces, 37 error messages. But it's saying here that it does not it cannot find the symbol method Println. So I purposely had misspelled that just to have a mistake. So that can happen. You know, you compile, you make a mistake, so you have to go back in and fix it. So then we recompile. And you always have to fix those errors then and have a clean compilation before you try running again. It's not going to work otherwise. I want to show you just a couple more things. So how do you suppose we would do a blank line? So if we wanted to have a print line that was going to produce a blank line, you know, various things you could imagine putting in here, but Java decided to keep it relatively simple. You just have an empty set of parentheses. So by having this left paren, right paren, that's basically going to produce a blank line for me. Then I could do system.out.println. Whenever you use quoting characters, it leads to, you know, potential issues. So suppose that I wanted to type, this is a so-called fourth line. Suppose that that's what I wanted to produce as output. So I wanted to kind of be quoting something inside of here. That's a problem because the quotation marks are used for quoting themselves. So if I want to try to include a quotation mark in the middle, Java gets confused. So if I hit compile, I get two different errors that it mentions. And what the compiler does is the compiler reads your program from beginning to end, you know, and when it encounters an error, when it kind of gets confused, it does this little pointer here. It's pointing at the F in the word fourth. It's pointing right here at this character. And it's saying that that's where it got confused. And what it's saying is, it expected a right paren. It's kind of an odd thing for the compiler to say. It's like it was expecting me to put a right paren there. But that's because it sees that you've closed the quote, you know, from its point of view. And so then why wouldn't you be having the right paren and the semicolon that would end the line? That's kind of the thinking. Well, but that's not really what we wanted to do. We wanted this to be part of our string. So another thing that's mentioned in chapter 1 is that there are what are known as escape sequences that allow us to do things like this. They all begin with the backslash character. So there's an escape sequence backslash with a quote. So I'm going to go here and turn this. Oh, by the way, before I do that, let me point out the color coding is helpful. So JGrasp was kind of letting you know it was confused because that's not in red the way the other string constants are. So, but if I make this a backslash quote here, and I make this a backslash quote here, now you can see the color coding is just right. So I'm embedding a two-character sequence that represents a single character. So backslash quote is a way of getting a quote if we embed that. And then, of course, you know, well, then what else is hard to include inside of a string? A backslash is hard to include inside of a string because backslash is used for escape sequences. So backslash is used to indicate a single backslash. So I've included a double backslash here. That's an escape sequence. Those two characters represent one backslash. So that two-character sequence is converted to one. What if you wanted 3 backslashes on output? How many would you have to have? The answer is 6. Have to have 6 of them in order to be able to compile and run and see 3 backslashes here. So these first 2 backslashes represented 1 backslash character. I can't quite select it right. These 2 represented 1 backslash character, and these 2 represented 1 backslash character. All right, I just heard a bell. That's the end of our time. There will be more in the lecture on Wednesday, and I'll be sending out some email in the meantime to let you know various things. I have those office hours through Zoom tomorrow from 1 to 3. Thank you.